So in this week's episode of Make It with Calvin, I'm going to take you guys through some of the design process and the machining considerations for this, the brass keychain bottle opener that you've probably seen all over the place. So let's talk about it. So the backstory on the bottle opener is pretty simple. It was yet another wonderful project request from Ashley over at Chip Builds, and initially this started out actually as a copper bottle opener. Well, I ran into some production issues with copper, which I'm not really going to go into. They're a whole other story. And also kind of figured that copper being it super soft might not work the best for a bottle opener. So we just both agreed that copper would be cool, but copper's not really the most, smart option probably. So we decided to ditch copper and go with brass. It's a lot tougher, looks nice, all that good stuff. So all that aside, there were a couple of design considerations that I took into place when I was designing these. Now one of them is I did have some space constraints given the fact that this is going to live inside a leather key holder. That in and of itself offered some considerations for how long it could be, how wide it could be, how thick it could be, all that sort of stuff. So we both decided that doing one that was just under 3/4 of an inch wide by just under 2 inches long overall would definitely be a good size. It would fit inside the holder but not take too much material, and that was that. Now when it came to actually designing it, there's a couple more things that I kept in mind. For one, I decided to keep this as wide as I could, but I did make it 0.725 inches on the width axis. The reason why is bar stock comes in usually 1/4 inch increments, 1/4 inch, 1/2 inch, 3/4, 1 inch. And while it would be cool to make it exactly 0.75 inches wide, pull that off reasonably, I'd have to bump up to 1 inch bar stock and I'd be losing a ton of material in the form of chips as waste, and that's just not efficient. So by making it slightly undersized on the width, nobody's really going to notice using it. Means that I can use 3/4 of an inch bar stock, saving money, winning step one. Now when it came to length, it was pretty much the same story. Now originally this was supposed to be 2 inches long, but I decided, you know what? This is yet another non-supercritical part, so it makes sense just to make it a little bit shorter. So I made it about 1.9 inches long. That's only because I wanted to have some material on the ends. So in case I bought pre-made blanks and they weren't exactly to the length as specified in the cut, most companies will say -0 inches plus 0.125 inches for the cut. Sometimes things fall through. Just to play it safe, in case my saw was cutting a little bit funky that day, didn't want to have any problems, so that's the reason why I decided to also go a little bit shorter on the length. Also, another thing to keep in mind is when you're cutting material, you're going to have about a 32/32 of an inch or so width that the saw blade is going to take out. And if you multiply that by a bunch of parts, all of a sudden, if you're cutting each blank exactly to say a little over 2 inches long, that could become a problem. So the idea was if I had a foot long of bar stock, I'd want to be able to cut as many usable blanks out of it, and potentially get 4 usable blanks get more like 6 usable blanks out of a foot versus 5, which doesn't seem like a lot, but when you're talking about $2 a blank, it adds up pretty fast. Also, another thing to keep in mind is the thickness. We decided to go with 1/8 of an inch because it was a nice round number, and it meant that I could use 3/16 inch bar stock, so I'd have about 60 thousandths of stock to hold on to on the bottom, which is more than chunky enough for what I'm doing. I ended up cutting some vice jaws with a 50 thousandths deep groove in them. Works perfectly. So those are some of the design considerations that I took in. Now, one other thing that I did is when it came to this slot here, I probably made it a little bit wider than it needs to be at just over 1/4 of an inch. But the reason behind that is I didn't want to be stuck using really tiny tools to finish the whole thing. I wanted to be able to go around it with a decently sized, say 3/16 end mill, and just rough out all the material and finish it really quickly. Every time I have to do a tool change on my machine, it adds time. That's not fun, all that stuff. So now that we're done with that, we can talk about the machining side. So we're going to jump into Fusion really fast, and I'll include some clips and we'll go from there. Okay, so here we have our part. For all of the first operations on this, we're just going to use a 3/16 end mill, a 1/8 inch ball mill, and a 3/16 drill. So let's dive in. So we're going to use that end mill to face the top off. It's intentionally going a little bit bigger than the stock is, just because I don't want the end mill plunging into the material. That's it. All we're doing is we're literally just skimming off the outer surface, so that way it's shiny, so it doesn't really matter. How, if we go a little bit bigger, it's not a bad idea. So then we come along and we're going to do an adaptive tool path around the outside because there's very little material to remove. That's the reason why it's literally just doing a contour, clipping the edges, then it comes along and it plows this out, which is pretty impressive to watch. Then we come along and we do a finishing contour. Should also be noted that for both the roughing and the finishing, it goes deeper than the part is thick. I'm going about 20 thousandths deeper on the roughing pass and about 10 thousandths deeper on the finishing pass. The main reason being is the front part, the bottom part of the tool tends to take the most abuse. And also I want to have the ability so that when I flip the part over, I can remove the excess material and locate my zero on the part without having to cut it to the final thickness. Makes life a lot easier, and it's just good safety insurance as well. Then while we have the 3/16 end mill in there, we're just going to come along and we're just going to rough out the front of the screwdriver part. This is mostly just so that way our ball mill doesn't have to remove any more material than it does, so it's doing more of a finishing pass, not a roughing and a finishing all in one. Then we change tools to the ball mill. It comes along and it finishes the front of this to the final thickness. I've decided to go back and forth instead of up and down, mostly just because I don't trust my Z-axis. And I also figured having the serrations going sideways made more sense visually as well, so it worked for me. Then in the case of this one, which is Ashley's bottle opener, I come along with the ball mill and I cut out the pocket in here. Nothing too fancy. All depends upon if the logo is better traced or pocketed. That's what determines how it's done. Then lastly, we come along with the 3/16 drill bit and plunge this out. Same story as with the roughing and the finishing contours. I'm intentionally drilling deeper just because the tip of the drill tends to take the most wear, so it doesn't hurt to go deeper. Then the part gets flipped over. And the only difference here is we're still keeping our 0 point in the center of the part. I figured that just makes the most sense for me personally, knowing my mill. And also we're going off the bottom because we have to remove material from the top. Having a known zero location to work from is extremely useful in this application, so that's the reason why we're doing that. Now I've decided to break the facing up into two operations because we have a fair bit of material to remove, so I want to come along and rough out as much of the material as I can while leaving a little bit of material behind, so when we do the finishing pass we get a nice surface. So obviously this one is cutting bigger than the stock again because as with the first op we don't want to plunge into the material. It's more important on this because obviously I don't want the part also to get skewed. That would not be good. Then we come along and do a finishing pass. You'll notice that for the finishing pass it's coming along and it's more following the contour of the part. This is an experiment. I'm probably not going to do that on a part like this. Didn't really save me any time and I wasn't a giant fan of it, but hooray for experimenting, I guess. Then as with the first side, we come along with the 3/16 end mill and we rough out the front of the bottle opener again. As with before, the only reason why we're doing this is we just don't want the tool to take any more material than it needs to. And also you got to remember when it's coming over to this side, this is an unsupported area. It's relatively stable, but I want to keep the load on it as minimal as possible. It's just a good idea. Then lastly, we come along with the 1/8 inch ball mill, and we come along and we do the finishing pass. And it should be noted that both this pass and this pass should technically be entering at the bottom and going up. This is an older program that I'm using, so that's the only reason why it's set up like that, but in reality it should be going the other way. Then while we have the ball mill in there, we come along again and we knock out our pocketing op in here. This is the same as the other side, and that's really all it takes to machine out the bottle opener. So next time we can talk about how we go about finishing it and all that good stuff.